if you use them, because, oh, I don't want to really put the part inside the bag, that's too difficult, so I'll just carry it like this. You haven't done squat. You might as well just pick up the part and say, I'm going to shuffle my feet. I don't care whether this sucker works or not. Okay, and it is not a work surface. We do not pull our part out of the bag, lay the bag down on top of our work surface, and put our part on top of the bag. If we don't have room on our work surface, we do not pull the part out of the bag, put the bag down and say, oh, the bag's a portable work surface. Wherever the bag is, I have a work surface. I'll just set it down there. No. Whenever I see that, what it tells me is the people were not given all the information that they needed. They're trying to do a good job. They've given me a bag. Okay, well, it's designed, well, the bag's not going to create any problems, so I can use the bag for these various things. They haven't been properly trained. Most people that I deal with wake up in the morning and go to work and try to do a good job. Rarely do you have people that wake up every morning and say, how can I screw things up? How can I wreck quality? How can I flush them down the toilet and make them close their doors and not get caught? Most people want to do a good job. Okay? So now we're giving you the information so that you can do a good job. So that's what a bag is. Okay? A bag only does anything when it's in it and it's closed. And when it's in it and it's closed, you can take that product anywhere. You can walk across carpet and you can hand it to other people. It's a static shielding bag. Okay? We're probably going to work on developing a program to identify when a bag is no longer functioning as an ESD. One extreme, IBM. Okay? You pull it out of the bag, you throw the bag away, you do something to it, you're going to put it in a bag, you put it in another brand new bag, close it up. Other end of the spectrum, when do you replace your bags? Because you reuse them, right? Yeah. Well, when do you replace them? When I drop the product in the bag and the product hits the floor, I think I need a new bag. Okay? Somewhere in between those two, that bag lost its ESD properties, and it might be a container, but it's not an ESD shielding metallized bag container from an ESD standpoint. So, I've been talking to Mike, may end up putting it into place. My thought is, every time you turn around and you put something inside the bag, you close the bag, slap a label on the bag, a permanent label, so that the label has to be ripped every time somebody else does something else with that bag. When a bag's got 5 labels, it's been handled, it's been loaded, unloaded 5 times. Never put a 6th label on it. 5 labels, throw it away, get a new bag, okay? Because it's been used. That little metallized layer is thin. It's so thin that you can see through it. Therefore, it doesn't take a tremendous amount of stuff to kill it or to degrade the quality of it. And the quality of your components will be no better than the quality of the products that you're using. And so somewhere between using a bag, a new bag, every single time, and, gee, my bag has no bottom, I think I need a new bag, somewhere in between there is realistic. And I like the idea of the 5 labels because I've seen programs where people say, well, the bag should have no more, this is when before, way before surface mount, when you had through hole, you know, and the components put little holes in the bag. I saw guys one program, they said the bag can have no more than 15 holes the size of a silver dollar. Okay? So you see people care about it. You hear that. If a bag has 15 holes in an area the size of a silver dollar, it should be discarded. If I tell you that, you know what's going to happen? You guys are going to be out there going, 1, 2, 3, 4. Just bought a bag. 6, 7, 8. Just bought another bag. 10, 11, 12. Bags aren't that expensive. Now, you don't want to waste them, okay? But you also don't want to keep buying them because people are trying to do the right thing. 5, you can look at a glance and you can see the number 5. It's easy. Okay, so you don't have to waste time turning around and counting. 1, 2, 3, 4. So anyway, that's something that may or may not turn around and come into place. But anyway, we ground things. People, devices, materials handled. Okay? We remove or neutralize insulators with ionizers. Now, we don't have ionizers, but I've been told to spend a little time on ionizers because they want it on the thing, just in case, because they're taking this. You guys are all going to be in posterity for this meeting here, for other training sessions. Now, what an ionizer does, An ionizer, it's got 4 pins on the inside of this thing, and they're high voltage tip pins, and as air passes through them, that little voltage, high voltage from the tip of the pin turns around and breaks the air molecule into individual ions, plus and minus, and the fan blows them out in the room. So, let's take our little field meter here. Okay. So, if I turn around and if I take this, I got a charge on here?
Yes.
Okay. Now, let's pull it down. Oh, you can't see it there. Let's pull this thing down into the string. Charge going away?
It's going, yeah.
Okay. If I do it this way,
Same thing is going down. Really no charge.
right. The ionizer, what was this charge? Positive or negative? Do you remember?
Correct.
Positive, negative?
Negative.
Negative. Okay. So, opposites attract. In the world of electronics and in life. So anyway, we turn around, we put a charge on here. It was a positive charge, right? Okay. So now this is blowing out an equal number of positive and negative ions. This is charged positive. It's now attracting all the negatives that are in this airstream. Okay. And as soon as it balances itself to where there's the same number of positive and negative that's on the cup, it's done attracting things. This is blowing out the same amount. We have now what we've called neutralized the charge. Okay? So, ionizers are used if we have what would be called a process necessary insulator, or in some cases a floating conductor. I've seen ionizers used where they take and the board is mounted in a frame and somebody's looking through a magnifier. Okay, so the board is not on the work surface, so it's not considered grounded at that point. It's a floating conductor. And so to make sure that there are no charges on that board, there's an ionizer that's blowing across it because it's floating. Because that person's going to be looking through the thing and then also maybe coming in with a pair of tweezers and manipulating something on the board and that type of thing. Okay, so that's basically what an ionizer does. Okay, and so we ground, we remove or neutralize, so we keep our plastic stuff away from our immediate work area. Air is a wonderful insulator. Shuffle your feet across the carpet sometime. Don't get within 3 feet of the doorknob and try to throw a spark. Ain't gonna happen. Okay? So if you keep your plastics away from your immediate work area, at least 12 inches away, you won't have a problem. That's the remove. And if you can't remove it, okay, if it's process necessary, then ionization should be considered to eliminate the charge there at the source. I run into a lot of this where people are doing assembly of things, okay? They build a board, and then the board's going into a plastic housing. Okay, well, I got charges on the plastic. Well, I got to use ionization because I don't want to load the board into this nice plastic housing. Cell phone companies, they're real big. They use ionization all over until they put the case together. And all of the repair companies, they can do all they want on the outside. As soon as they crack the case and open up the inside, they got to have an ionizer going because it's now in a plastic case that's been opened, and now it's subject to charges because of the plastic. Okay, so they eliminate that, and then we shield ESD-sensitive devices when they're stored or transported outside of the EPA or the ESD protected area, which in your case pretty much means you guys do a nice job of double protection, if you will. Parts come up, they're in a bag. You open the bag, you pull the thing out, you work on it. When you're done, you put it back into the bag. Most cases, right? Okay. And even though it still may be in a quasi-ESD area, people aren't grounded because we're not controlling the floors and that type of thing. So you're doing a nice job on that.